Again, welcome to Database Management System course. Again, in this lectures, we're going to cover the basic concept of sequential query language, which we call the SQL. So again, this lectures is Introduction to SQL. Our main objective is to define the terms, some of the database terminologies. Also, we are going to define a database using the SQL Data Definition language. In SQL, we have two major languages, or I'll say two divisions of the SQL language. One part is called the Data Definition language. The Data Definition language are the scripts that we use to create items, such as creating a table, creating a view, inserting values or items in a table, etc. And we also have the data manipulation language. Data manipulation language is based on writing queries. So that's the next objective. Write a single table queries using SQL. Again, this is a basic concept, so we are not going to join two or more tables. Sometimes we can write a query whereby we can join two or three tables, and we get data from all these tables. An example, let's say we have an Amazon database system. We have a table for customers. Let's say we have a table for products. I can write a query whereby I'm going to pick a customer information from the customer table, and I'll pick a product from a product table, which means I have to join these two tables together so I can get information from them. We will do that in our next lectures. In these lectures, we consider only one table. Let's say we have a customer table. I need all the customers from New York City, or I need customers that spend more than $1,000 in a month. So these are queries. So data manipulation language make it possible for it to select a subset of the data set. Also, we're going to learn how to establish referential integrity using the SQL. So we start with the SQL overview. The SQL again stands for Structured Query Language. Some textbooks say sequential query language, but I think the correct term is structured query language. Structured query language. And the structured query language is normally used for relational database management system. So a relational database management system is based on relations. Relation is a table. So we may have 2, 3, 4 more tables, which we can use the term entities. Then we're going to connect these tables together. They may have a relationships. So RDBMS means Relational Database Management System. And the definition is a database management system that manages data as a collection of tables. And these tables must have a relations. So as a collection of tables in which all relationships are represented by common values in a related tables. So the whole concept of a relational database management system is we have a database system which consists of relations or tables, or we can use the term entities, 2 or more entities, and they have a relationship between them. I think we went through these lectures in our previous units. So the SQL environment, first, this are again some few definitions we should go through. First, what is a catalog? A catalog will be a set of schemas that constitute the description of a database. So the main thing is the description of the database system. And it's called a catalog. And also we have a schema. We know schema goes with diagram or sketch. So, and the catalog goes with information about something. For example, we know a store may have a catalog. A catalog, so a store in a catalog means it will consist of the products that the store is selling, the description and the price of the products. The same thing pertaining to database here. When we say a catalog in a database system, again, we mean the description of the database system. It can be the diagrams, example, the schemas. And now a schema also is a structure that contains the description of object created by a user. It may have tables, views, and also the constructs. We also have a data definition language. So this is part of the SQL or structured query language. So data definition language consists of commands that define a database, including creating, authoring, and dropping tables, and also establish constraints. So from here, we can know that the data definition language consists of commands that we can use to create our database and also the database objects, and also create relationships between the database tables. Now, if I don't need a table, then I have to delete it. We have a command that make it possible to drop the tables or delete the tables. The next is the data manipulation language, which consists of commands that maintain and query a database. So database manipulation language basically is based on queries. Mostly we are going to use a select statements. We want to select a unique something, we may use select and distinct. We can select an item, then we sort it. We can use the command order by to sort. If we want to select everything, there's a command for that. We can use where keyword to apply a condition. For example, I need all the students that their grade is A. So we are going to use where grade equal to A or grade is A. Again, we will go through this. Then also we have the data control language. Data control language is also part of the SQL, and these are the commands that make it possible to give privileges to users of the database. So for example, in a company, a supervisor may see a specific information about customers, customers balance, personal informations, but we can allow junior staffs, clerks, not to see it. So we can give a privilege to a supervisor to see necessary information or to even have access to necessary devices, why some other employees cannot. But here again, we are dealing with databases, and so our main concern is data. So data control language will make it possible for some senior employees to get access to some data system or database information, while some employees with lower rank cannot have access to it. So we start with the SQL data types. Data types means the type of data we can store in that very attribute or the column. So for example, if the data type is a string, as we can see it here, it means we can only store characters, and it can be in double quotation as a string. So characters can be a word like Charles or state, New York is a string. And sometimes string can be only one character, etc. And sometimes we may even have an empty string, which means there's no in the character. So if we want to declare data type as a string, we use the keyword char, C-H-A-R. And we say this will store the string values containing any characters in the character set. The char is defined to be a fixed length. We also have the varchar, so we can see the varchar, that's character varying. So when you are using varchar, you have to specify in the argument the number of characters you want. So if we have the argument here, we have 500, then we're going to have up to 100 characters. Again, we're going to see the examples when we write some of the queries. We also have the number, which is the numeric. This will be values, let's say 100, 200, 7, etc. So the data type, we use numeric. Or we can use an integer. Integer means we are going to store exact numbers with a predefined precision, and the scale have to be of 0. But here, numeric, we can store exact number with a defined precision scale. So this means what we mean by precision and scale, especially precision, we mean the decimal places. So if it's a numeric, I can store 20.45. But if it's integer, it can only be 20. There's no decimal number 0.45, no. So my data type is integer, means I'm using a whole numbers. Numeric can be whole numbers, it can be decimal numbers. We also have a temporal type. Example here will be the timestamp, or timestamp with local time zone. And the example here, always the keyword temporal, even in data mining, data science, it means something relating to time. So if I have a temporal visual chart or visualization, we say it's in temporal, it means it's a time series chart, a chart that goes with time. The data changes with time. So the horizontal will be in time. So here we say it stores a moment, an event occurs. Moment again means the time. Using defined fraction of a second position. So the values can be adjusted to the user's section time zone. We also have a Boolean. Boolean means we can have true or false. Boolean is binary numeric system. You can either say we stored value is true or false. So DDL stands for data definition language. DML stands for data manipulation language. DCL stands for data control language. And as we said, data definition language, we normally use it to define our database. So data definition language, we normally use it again to create our database, a database object, and again, control the structure, for example, the foreign key, primary key, etc. Then data manipulation language is based on writing queries. We want to select some specific records from our database system. Then data control language is mostly for privileges. We want to give a privilege, security issues, etc. So here we say the data definition language define the database. For example, create tables. We can also create indices. We can create views. We can also establish foreign keys or relationships. And if we don't like a table, we can drop it or we can truncate the tables also. This is again physical design. Then the data manipulation language, we can load the database, we can insert data, we can update the data, and most importantly, we can do our select statement to write queries. Anytime we talk about data manipulation language, the first thing that will come to our head and our mind will be selection, writing queries. But also we can set, when we set the values or using the insert or update command is also data manipulation language. Then the last one, data control language, again to control the database. Example, we can grant some privileges or we can even revoke some privilege. So SQL database definition, here we start with the data definition language. As we said earlier, is the main language that we use. And one of the main command is create, so major create statement. So create a schema. This will define the portion of the database owned by the particular user. Then create table. This will define a new table and its columns. Create view. This also will define a logical table from one or more tables or views. The reason why we use views make it possible for us to access our data very quickly and also optimize the process of using the database to access data, etc. Other create statements can be the character set, correlation, translation, assertion, and domain. And we may discuss this as time goes on. So what are the steps in table creation? Well, before we create, again, we know database, the first thing we need to do is designing process. If I want to create a database for the first time for a company, the first thing I want to know is, I know database is used to store data. So the first thing we want to know what type of data we can store or the company is going to store. For example, if it's a bank, it will be a banking operation data. If it's a retail business, then retail operation data. So let's say if it's a bank, I may need customer information, the type of banks, the bank's account system, employees information. So we have to get all these. Now, after we identify the data types for our attributes, we create the table. For example, customer will be customer table. Employee, we may have employee table. The next step we need to know is the business rule. The business rules will make it possible to connect the tables together. For example, I think the best way I would even say is about school. We have a school that said, okay, we have a table for students, table for courses they are taking. The school rule said, business rule said, student can take only one class at a time. So here we can create a relationship one-to-one. One student takes one class. Now the school says student can take up to 6 classes at a time. Then we can have one-to-many relationship. So when we are creating the relationship between tables, there are major 3 types: one-to-one, one-to-many, or many-to-many. So after we define our relationship, then the next step, we have to know the attributes of the table, and that's what we are discussing here. So first, we identify the data types for the attributes. Then we identify the columns that can and cannot be null. For example, we know the primary key field can never be null. So when we set it, we have to put that constraint there that it cannot be null, not null. Because the primary key field is the field that uniquely will identify the record uniquely. So for example, if I have employees information, the primary key field maybe will be the employee social security number, or a specialized employee ID, which means 2 employees cannot have the same ID. So a field like this cannot be null. So we have to identify columns that cannot be null. Then also we identify columns that must be unique, which means the information in that column, only one record at a time we will have that information, like the primary key field. Social security number, only one person have his own number. It's unique. Then we need to identify the primary key with the foreign key mates. The reason why it's foreign key because we want to create a relationship. So if we want to create a relationship between 2 tables, we may have the primary key in customer table, and the same field will be a foreign key or secondary key in let's say, product table. So we can create a relationship. One customer can buy 1 or more products, or 0 to more products. Some customers don't need to buy anything. Then next, we have to determine the default values if we have it. For example, if I'm 100% sure all my customers are from New York, I can use the New York State as a default value for state field if I have a state column field. Then we need to identify the constraints on columns, the domain specification. Let's say age. Age should be between 0 to 105, or between 0 to 120. There's no way a person can be more than 120 years. So there must be a constraint. Also create a table and then the associated indices. So let's go through some of the syntax. This is our syntax for creating a table. So create table will be our keyword. Everything is in the uppercase characters. That's our keyword, create table. Then table name will be the name you choose to name the table. For example, I have customer table, so I would say create table customer. Then we have our column definition. So the column definition here will be the data type of the column and the column name. So let's see ID. So we can say number ID, which means the column name is ID and the data type of, or what type of data we can store in the ID is number. Now, create table, column definition, and then table constraint. This will create our table for us. Now, if I don't need a table, I want to delete it, then we can use delete also. So here we say where column definition equal to column name. The column name, we have the domain name, data type, the column constraint clause If there's a default value, we had it, colored cross also. Now the main thing we want us to know here again is create table command. And it have the attributes, which will be the column name and the data type. So the following slides here will create a table for this enterprise data model. We have, this is a year diagram or ERD. We have a table named customer. It has only one field, customer ID, and we put one data inside customer ID. And the underline here means it's a primary key field. So customer ID is a primary field. But then we have one field again, which is customer name. So in general, the customer table have two fields, the customer ID and the customer name. Again, we are going to see the SQL script that will make it possible for us to create this table. So second table will be order. Order, we have the order ID as the column name, and also it's a primary key field. Then we have a customer ID, then we have the order date. The customer ID will be a foreign key because the reason why it's a foreign key, because a foreign key is a field that is already a primary key field in another table. So I quite remember customer table, the primary key field is the customer ID. And there's a relationship between customer and order. And we have column ID in order. So that will be the foreign key to connect the two relationships. Then we have another table named order line. It has a quantity attribute. Product table have a product ID and standard price. So let's see how we create. So first we create a customer table. So we name it customer T. So we use the keyword create table, customer T. We have customer ID. Data type is number. We make sure it's not null because it is a primary key field later on. Then we have customer name. We also make sure name is very important. So we make it not null. By here, it's a string. So it's a varchar. We can enter up to 25 characters as a string. The customer ID is a number. So we enter digits up to 11 and 0. Then we have address, also it's a string, but address can be empty, no problem. Then we have customer city, also it's a string. Customer state by default, we use 2 characters, NY, MO, MN, etc. So you can see char 2. Then we have customer postal code, varchar, we say 9. Now we want to make the primary key field as the customer ID. So here we say constraint, customer PK or the primary key, and the primary key will be the customer ID. So the same step, we are going to create the order table or order T. We have the 3 fields. Then we do the constraint for the primary key field as the order ID, but we also have the foreign key for customer ID. So this will make it possible for us to have a relationship between customer table and order table using the customer ID as the field to create the relationship between the 2 tables. So we go to product table, the same thing, use the keyword product table. Then we list all the product table attributes, which are product ID, product description, product finish. Product ID again is a number, which means it's a value. Varchar for product description is a string. The number of string will be 50 characters. Product finish also is a string. The number of string is 20. Then here we have check product finish in. So here we are making sure it's in product finish in these fields: cherry, natural hash, white hash, free oak, natural oak, and walnut. Now we have the product standard price also, which is a decimal number. Then product line ID, which is integer. Then we create again the primary key field for product ID as a primary key field. The last one will be the order line T. The attribute again is order ID, product ID, order quantity. We have their data type. Primary key field cannot be known, so not known. And also product ID cannot be known, not known. And we're going to use that as a foreign key. So we have a constraint for primary key as the order ID and product ID. But we also have the foreign key as order ID. So defining the attributes and their data types, here we have the create table, that's the keyword. The table name is product T. We have the product ID, the product description, and product finish. These are the attributes. Then we have a product standard price, product line ID. And these are all their data types. So we have integer, decimal number, voucher, string, and number. And we say product description cannot be null, so we have not null. So that's the non-nullable specification. Product ID is a number, but not null. Then product description, voucher 50, product finish is 20 characters. And here, so we are doing checks. So we are checking the product finish. The product finish in, we have cherry, natural hash, white hash, red oak, natural oak, walnut. And as we see, primary keys can never have a null value. And we have to use the keyword constraint, the product, PK primary. So the primary key will be product ID. And the same thing with the order line T. We use the keyword create table to create it with 3 attributes. We made the primary key field as the order ID and product ID. And foreign key will be order ID, and foreign key 2 will be product ID. Now, controlling the values in attributes, we can see we have the order T. These are the 3 attributes we saw before. We use the constraint order, and we change the primary key field to be the order ID. The foreign key will be the customer ID. Then we have create table product T. We have the 3 attributes. And also we have a check product finish in. So product finish attributes. If you have cherry, natural hash, white hash, red oak, natural oak, walnut. That would be the domain constraint. Now, identify the foreign keys and establishing relationship. So when we create our table like customer T, we have all these attributes. Now, to identify the foreign key will be always, for example, customer ID is a primary key. So a foreign key will be a key that is a primary key in another table. So here for now, we are identifying the primary key field, constraint customer primary key field, customer ID. Then the other T also the same thing. We have the 3 attributes here. They are data type. We use the constraint primary key, and the primary key field will be order ID. And then the foreign key will also be the customer ID. So we have, and this means customer ID is a primary key field in another table. So next we move the data integrity controls. We say that referential integrity is very important, especially when we are writing queries, joining two or more tables together. So referential integrity means the constraint that ensure that the foreign key values of a table must match the primary key values of the related table in one-to-many relationships. So what, again, this means is that if I have two tables, customer and product, I have customer ID as a primary key field in customer table. I have product ID as a primary key field in product table. Now, if I'm going to have a relationship between these tables, I will have a foreign key. So a foreign key in my second table will be, that field will be a primary key field in my first table. Let's say product table is my first table. So the primary key field is product ID. Then we can have product ID in the second table, let's say customer, and this time it will be a foreign key. So referential integrity makes sure that the constraint that we ensure on the foreign key values of a table must match also the primary key values of the related table of the other table. So the restriction on referential integrity, if we selected it, it will delete of primary records will be restricted. Update of primary records will be restricted. And also insert of dependent records will be restricted. So this example, we have a customer. The primary key field is customer ID. Order, the foreign key will be customer ID, as I said. So foreign key always is a field that is a primary key field in another table. So I can create my relationship one-to-many using the customer ID. Here we say the restricted update, a customer ID can only be deleted if it is not found in the other table. So if I have other ID in the other table, I cannot delete customer ID. I mean, if I have a customer ID in the other table, I cannot delete it in the other table because I have customer ID in the customer table. Sometimes we may have tables, and the goal here is that we want to change it. So we can change the table by using the keyword alter table. So alter table statements allow you to change the column specification. So alter table, the table name, then alter the table action. So a table action can be, for example, adding a column or altering a column, changing the content of a column, or dropping a column, that's removing it, the attribute, or add table constant. I mean, add a table constraints. The constraint here can be primary key, field, foreign key, etc. So example here, we have alter table, that's the keyword. We want to change something, keyword. The table we want to alter is customer T. But here we are going to add a column. Since we are changing the structure of the table, we use the keyword alter table. And here we are adding columns. So when we alter table, we can add data to the table, we can change the columns, anything we want to do. So removing tables mean, alter table means you want to change the content of the table. Removing table means you want to drop the table, you want to delete the table. So when I'm removing the table, I'll use the keyword drop table. So drop table statement allow you to remove tables from your scheme. So if I execute drop table customer T, to delete the customer T table from the database. We also have the insert statement, which we can use to add one or more rows to a table. So inserting into a table will be insert into customer T values. And then what are we inserting? The first, again, let's assume the customer T table has 20 attributes. So we have to specify which one comes first, and that will be so the first value 001, let's say that is the customer ID. Then after that, we move to the second field, and that is the data we're going to store. And sometimes we can also say insert from another table. So insert into our customer T, but at the same time, we are selecting all from the customer T also, where the customer says is California. So this means I want to select all the customers' information where the customer is from, or the customer state is California. And also we can create tables with identity columns. So here we have create table, the table name is customer T. We specify the customer ID, start with 1, increment by 1, mean value by 1, maximum 10,000, no cycle. And here we have second field to be customer name, data type is varchar, number of character is 25. Again, customer address, customer city, the data type, state, etc. Then at the end, we constrain as a customer PK, primary key, and that will be the customer ID. We also have a delete statement. Delete statement means, drop statement means we are deleting the whole table. So even if the table have 100 records, we are deleting everything with the table. But delete statement means you want to delete only the records in the table. So I may have 100 records in a database system in a table, and I may delete only 10 of them. So delete means, again, to delete the records or information in the table. Drop table means to delete the whole table. So here we can see the keyword delete from customer T, that is customer table, where the customer set equal to Y or HI. So this will delete all the rows or records that the customer is from Y state. We can also use the keyword update statement. Update statement means we want to edit or modify the content of the table. We have to specify the content. So example here, modify data in existing rows. So we have update, product T, and we have set product standard price to 775 where the product ID is 7. Then we can also merge statement. So we use the keyword merge into the product T as prod using select product ID, product description, product finish, standard price, line ID from purchases T. So you can see we are merging into a product T as prod using the query here. Select product ID, product description, product finish, product standard price, product line ID from the table name purchases T as PURCH on PROD product ID equal to purchase PURCH dot product ID also. And we say when match, they will update. But if they don't match, then they don't update. So when not match, then insert. And also we have a schema definition, which is the control process, storage efficiency. And this will lead us to the choices of indices and file organization for base tables, file organization for indices, data clustering, statistics maintenance. So in general, this is what we're going to focus. Select statement. Always select statement, we start with the keyword select. Select from where? So select all the possible columns. If all the columns we use asterisks or a specific column. So that's what we are selecting from. Where the condition we want. So the condition at which the row will be included. Then we can group by, categorize the result. We can have having. Having means we are going to indicate the condition that which a category group will be included. Then order by means we again sort the result. So these are the keywords. Select means to select an item from, where we are selecting the item from, and where we are selecting the item from. Then we can categorize it, the result. So we group by, and we can use having to indicate the condition at which the category group will be included. So this is a SQL statement. Select from identifies involved tables, where group by, having, and then select, then group by again. So we have example here, select. We are not selecting everything. We are selecting a specific attribute. So select product description, product standard price from product T. So this means I'm selecting only two attributes, product description, product standard price. From what table? Select from, so from product T. Do we have any, we can end right there. Do we have any condition? Yes. Here they say if the product standard price is less than 275. So this means I'm going to get the result of product description, product sale from a table named product T. But we only get this information if the product standard price is less than 275. We can also do the select example using aliases. Like for example, select, our alias will be CUST cost dot customer name as name, then cost dot customer address from customer V cost, where again the name is whatever home furnitures. We can also use the count aggregate function to find the total. So I can say select count all. So this will give me the total if it's 100, 200, any amount there. So select count function. And count is again an aggregation function to find the total. So to find the total, then give us from the order line to where the order ID is 1004. We also use binary operators or binary operations of operators, and or and not. And means all the conditions have to be true in order to execute. Or means only one condition has to be true. Not also means only one condition has to be true. So we have and or and not operators for customizing our condition in where. So let's see this. We have select, product description, one of the fields, product finish, product standard price. So we need 3 fields from a table name product T, where the product description like should be %desk or, so which means only one of these statements will execute, where product description like or product description like %table. So this is an example of a Boolean also query. Remember, all means one of the conditions have to be true to execute, and means all the conditions have to be true to execute. So select product description, product finish, product standard price from product T, where product description is this, or product description like, and we have a product standard price greater than 300. So select example using the Boolean operators again. This is the previous example slice. We can select the 3 columns from the table name product T, where the product description like desk, %desk, or the product description will be like, so this is our banner. So this means only one of these conditions have to be true. either the production description like is table or desk. But N means after one of these, always the product standard price will execute. And here, if the product standard price is greater than 300. So here, so with the parentheses, you can override normal precedence rules. In this case, parentheses make the odd take place before the N. That's the same example we have here. Also, we can sort a result. When we sort in a result in SQL, we use the keyword order by. So let's see this example. Select customer name, customer city, customer state from the table name customer T, where the field customer state can be only in Florida, Texas, California, or Hawaii. So the result we get will be based on these four states. Then when we get the result finished, we use the keyword order by, customer state, and customer name. So we want to put it in order. We can also categorize the results using group by clause. So we have the scalar aggregate. Scalar means single value returned from SQL, or vector aggregate, multiple value returned from SQL. So select customer state and count the number of customer states we have from a customer T, then we group by customer state. So here we can use the single value fields and aggregate function if they are included. We can also use the halving clause. So select customer state, we count the number of customer state from customer table. We group by customer state by putting it in order, sorting. Then halving count. Now we want to count only customer state that is greater than 1. So here we say like the word clause, but it operates on groups, which is categories, not on individual row. Here only those groups with the total numbers greater than 1 will be included in the final result. So having count make it possible for us not to count all the customer states except if it's greater than 1. And this will be the conclusion of our lectures. Again, this lectures is based on the basic concept of introduction to SQL. And we cover the data definition language. We saw some few scripts, especially how to create a table, insert, values, alter. This again, data manipulation language. We did a select also. So in our next lecture, we will continue with the advanced stage of SQL, where we're going to learn how to join 2 or more tables before we write our query, and also how to use the data control language section also. So again, thank you for your time and wish you the best.